Welcome, Farmington High School. This is Unit 7 Notes 5, Independent Events. Learning target. I can determine the difference between and solve independent probability solutions. A fair number cubed is roll. Find the probability of each of the following. Alright, so when I look at this, the 2, a fair number cubed, that is a fair number nice. So the probability of a 2 is not a 2. Probability of a 2 is 1 out of 6, so then we got to do the 0.167 thing. Probability of even. I know that a 1, a 2, a 4, and 6 are even, so there's 3 possibilities out of 6, which is 1/2, which is 0.5. The prime one we did, and remember that's 2, 3, and 5 for prime numbers, which is another 3 out of 6, which is 0.5. So make sure you are reviewing and getting these in a lot of the time. A fair number cubed is rolled twice. Find the probability of each of the following. So 2 4s. So the first 4 would be 1 out of 6 times another 1 out of 6, which would be 1 times 1 is 36. 1 times 1 is 1. 6 times 6 is 36. So 1 divided by 36 is equal to 0.027 repeating, it looks like. So the probability of a 2, 1 out of 6, times then a 3, 1 out of 6 again. So we're going to say that's 1 out of 36, which is 0.027. Repeating. Probability of a 1, so that's the 1 out of 6 thing again. Then any number. So we don't care what number it is out of 6. That's just like multiplying by 1. It's just going to be 1 6 equals 0.167. Alright, so just review these things. Alright, you're not going to be perfect. Alright, but then we got to talk about some of these probabilities. For example, probability of successful outcomes, possible outcomes, probability of rolling a 4. So we did the 1 success out of 6. We've been doing that. Independent events. The result of one event has no impact on the result of the other event. Alright? So if you're doing some things and you're choosing this and that and the other thing, and the first has to do with how many dice, and then the next one has to do with how many face cards, and cards and dice have nothing to do with each other, so they're independent. Oh, look at this. Rolling a dice, drawing a card. Now, the dependent events, the results of the first event impacts the result of the second. So drawing an ace from a drawing, and then drawing a 4 from a standard deck without replacement. So if I don't put that ace back in the deck, now there's not even 52 cards, there's only 51. So you got to start listening and paying attention to very specific things. So let's talk about this. Choosing the color and size of a pair of shoes. So with choosing the color, so if I choose red or blue, does that have anything to do with if I pick out 12 or 11? Right? That shouldn't matter. Unless the store person comes out and says we don't have 12s available in red, then that would matter. However, in all these examples, what we want you to get out of this is that these are independent. This is an independent one, right? Because they don't have a direct effect on each other without the store clerk saying they're out of the 2. All right? So you got to realize, hey, these don't affect each other. Let's just roll with it. So number 2, you need to choosing the winner and runner-up at a dog show. Okay? This should hint to you, for number 2, that we need to circle dependent. All right? Hey, you can't have a runner-up until, if there's 8 dogs at the dog show, you pick a winner. Now there's only 7 dogs to choose from for the runner-up. So they're directly dependent on each other. So 2 is dependent. So I'm going to put I'll put an I. Let's see what number 3 is. 3, choosing a president, vice president, secretary, and treasurer for student council, assuming that a person can hold only one position. Right? These are definitely dependent. right? Maybe 50 people ran for president, and then out of those 50, only 20 want to be vice president. Or you just got to know you got to pick the president first before you can tell who's running for vice president. Then we have number 4, selecting a fiction book and a nonfiction book at the library. Remember, these two are opposites of these, right? So you got to pick this fiction book. So that's going to be 1 out of all the fiction books, and then this is going to be 1 out of all the nonfiction books. So those don't depend on each other, so that's why they get the word independent. So 4, you need to circle independent. All right, so now we're going to flip over, and you're going to start doing 5, and we're going to do some answers to this thing. So now in number 5, it says, at a picnic, Julio reaches an ice-filled cooler containing 8 regular soft drinks and 5 diet. He removes the can, then decides he's really not thirsty and puts it back. What is the probability that Julio and the next person to reach into the cooler both randomly select a regular soft drink? Okay. So, Julio took a drink out, and then he put it back. So, there's 8 regular and 5 diet. So, I think there's a total of 13. Right? Now, they're talking about a regular. So this is going to be independent. Right? Here's why. 5 plus 8 is 13. So out of 13, they both select a regular. So that's 8. Times, well, Julio put his back in. So there's still 13 soft drinks in the cooler. And then now you also have this next person, whoever it may be, still has a chance of grabbing 8 out of the original 13. So then if you're going to find the probability of this, you just do 64 divided by 169. And sorry, I didn't grab my calculator here. 64 divided by 169. And you get 0.379. Right? So because that key word in there is puts it back. Because he puts it back, it didn't change what the probability of the second person grabbing a regular soda. So that's why it's independent. 3 cards are drawn from a standard deck without replacement. Find the probability of drawing a heart, another heart, and a spade in that order. So I would tell you right now you should come down here. Alright, you should come down here. And the first thing I would do is write multiplies in the middle. Right? And I would write there's 52 deck cards in the deck, and then you take one out, there's 51. Take another one out, there's 50. Alright, now it says find the probability of drawing a heart. So the first time there was 13 hearts. Now, since I know that we drew one out, now there's only going to be 12 remaining hearts. So when it says another heart, it's 12 out of 51, and then a spade. Well, spades are full, so there's 13 there. So then I would have said that these are dependent upon each other. And so I probably would have did 13 times 12, got 2,028, and I would have divided it by this big number, 50, 52, 50. Remember, multiplication isn't in an order. 1, 3, 2, 6, 0, 0, and then I can find out probability. So 2028 divided by that second answer key. Make sure maybe you still need practice using that. 0.15. All right. So those were definitely dependent, and you can tell they didn't replace those cards. That's a big blinking flashing light for you to pick dependent. All right, next one. 7. There are 3 miniature chocolate bars with 5 peanut butter cups and a candy dish. Liz chooses 2 of them at random to eat. What is the probability that she chooses 2 miniature? So this one doesn't say anything about putting them back. So I am going to go with they are dependent upon each other. So there are 3 and 5. So that's a total of 8. Well, the first one is 8. The second one, if she doesn't put one back, is 7. So she chooses 2 of them at random. What's probably she chooses 2 miniature? Well, there's only 3 to start with, and if I take one the first time, now I'm at 2. Fun fact for you, if you want to get good, when you multiply straight across. So you're doing like 3 times 2 is 6, 8 times 7 is 56. Alright, so you could do 6 divided by 56. And you would get 0.107. So those are the probability of that, and those are definitely dependent events. Alright, moving on here. 8. In a state lottery game, each of the 3 cages contains 10 numbered balls. The balls are each labeled with one of the digits from 0 to 9. What's the probability that the first 2 drawn balls will be even and that the third will be prime? Alright, so the first ball. We're looking for an even. Remember, the probability of even would be 2, 4, 6, 8. Alright. I don't think 0 is an even number, so I'm not going to put it. So I think the probability of the first one is 4 out of 10. Alright. Then the next ball is going to be probability, would be 4 out of 10. Probability of prime numbers, I would have said it's 2, 3, 4 goes, nope, 5, 6, nope, 7, 8, 9. So I would have said this is 4 out of 10 as well. Well, what do you know? Now, hint, these are all out of 10 because this cage and this cage, there's 10 put in both of them, so they're not going to be dependent upon each other. So these are all independent. And what I see when I see all these even numbers is I should divide by 2. So I probably would have reduced this and just wrote 2/5 times 2/5 times 2/5. And personally, 2 times 2 is 4 times 2 is 8. And 5 times that is 125. So 8 divided by 125 would let me know that there is 0.064 chance of it happening to be an even, and then a prime ball at the end of the lottery. 2 more. Hang with me. Find the probability of drawing 3 cards of the same suit without replacement. This shouldn't be too bad. 3 cards of the same suit. Now, there's 4 suits, but no matter what suit I pick, there's 13 in a suit out of a grand total of 52 cards. Now, if I take one away, there's going to be 12 in that suit out of 51. And if I take another one away, it's going to be 11 out of 50. Did I pick a suit? No, it doesn't matter. They're all going to have the same probability. The hearts are going to have the same probability without replacement as the diamonds, as the clubs, as the spades. So really, to me, I just got to be able to add all these up together. And when you do that, I did it already. Look at this one. 13, 12, 50. It's going to be 0.05 again. So this is going to equal 0.015. Now, when you do that, notice I had to drop 1 each time. So that should be a big hint that you are looking at dependent events. A cage contains 3 white and 6 brown hamsters. Maggie randomly selects one, puts it back, then randomly selects another. Puts it back. That's a big hint. They're going to be independent. Then selects another. What's the probability that both were white? So I got 3 out of a total of 9 times, she puts it back, 3 out of 9 again. Alright, when I look at this, guess what? 3 times 3 is 9 over 81, which is 1/9, which is going to be 0.1111 repeating, so it's just 0.1 repeating. Alright, so looking at that, you should have the skills to tell if they're independent or dependent events, so you know how to multiply them together. Remember, you still have permutations and combinations for probability, so make sure you're trying to keep it all straight and maybe have a cheat sheet for when you're doing your homework and things like that. Thanks for listening. Have a great day.